Hello and welcome. It's me, ya boy. It's von Fahrenheit here, back in the building, baby. Today we're gonna continue as we always do. I was planning to stream a little earlier today. It seems that's how we're gonna do this. I always plan to stream earlier than I do, and then it ends up being late anyway. But it is what it is. I didn't really have a lot to do today. I just ended up playing a video game for way too long. And then the things I actually had to do got delayed. And now I'm here, back on the stream again. So what did we do last time? That was yesterday, wasn't it? So we set up multiple hitbox interaction. I think that's about everything we did. Let's see, yeah, like these, you can interact with these. Oh right, you can jump on this now. I gave him two different HP variables. You can see the HP on the coin counter of the glass. And then once you break it, you could also break it instantly with a spin jump. Just a neat little thing I added. He is just walking forward, right? And the glass actually goes away when you break it. Very nice. So what we want to do today, I think, is kind of irks me that big spike isn't 1 pixel further down. No, top spike, I think it's called, right? Here. Let's just move it 1 pixel down, like so. So the outline maintains its thickness. I think what we want to do is add terrain interaction today. That's pretty neat, right? I'm not sure entirely how we're gonna do it, but we're definitely gonna do something. We are definitely going to do something. There are a few ways we can do it. We definitely want to prevent the boss from like falling into a pit. Like that should not be a thing that happens ever. We can go to what do I call it? Apply speed, probably. Here, instead of just zeroing Y speed, we can just leave that as is. And then here we add Y high. If Y high is somehow 0, then we just skip this. It's never gonna be 0, but yeah, if it is 0, I don't know. And then Y low, and if this is greater than, let's also do this, I guess. Here, and let's give this a name, I guess. Let's call this move done. Adjust here. We're just gonna cap the Y coordinate, the downwards Y coordinate at, let's see, what is this? What is this coordinate here? This is gonna be the cap, right? 25, what is that in hex? It should be 19, so 90, because we're already checking for high byte 1. BCC done, otherwise we do that. That should not look patchy either, because we're moving the boss before. So we're moving the boss, then we're immediately applying this correction, and then we're drawing it. So this should look smooth as well. It shouldn't like flicker or anything. Also, let's test if this new system works. I also gotta get some music going. That will do. Oh. Okay, let's see what happens when the boss like gets here. He should like go down here, right? And he does. That like really snappy speed was not good. And as you can see, he doesn't fall into the pit because this is actually the cap of his This is the bottom cap of his movement. I kind of want him to like snap up on top of these. Like, so what I want here, let's see if we can find a good example. Let's back off a little bit here. So here, this is perfect. Let's get that. Paint, please. Here. Let's see here. So, here, here, these like small steps, we want the boss to just walk up these, right? If it's only one tile, we want him to walk up. But if let's say this thing was like twice as tall. Ah, damn it. I'm trying to illustrate something here. Paint, work with me, bro. Paint, bro. Here, like if this was like twice as tall, then the boss should not walk up at all. Instead, he should just break these. If the like barrier he's walking into is 1 block tall, he walks over it. He like goes on top here. If he's walking into something that is 2 blocks tall or more, he should break it. So how do we detect this? Well, we certainly don't use this routine. We're probably just going to remove this routine entirely at this point, I think. This wastes. This is a very inefficient routine for the stuff we want to do, because it includes a lot of like checks that we are not going to make use of. So we're actually gonna code this on our own, and we're probably just gonna look for tiles. Instead of like looking for like map 16 acts like or anything, we're just gonna look for anything that is not tile 25. So anything other than air will be solid for the boss, which is fine, I think. So like if we played like coins here, who would be able to walk on them? That's pretty funny, but it's just an optimization, really. So instead of this routine, we're going to remove this. Let's see, how do the speed routines work? If I recall correctly, all we have to do is, so let's show with X speed first. This is another example of speed optimization, and we really do have to code this boss and optimize for speed. We cannot optimize for space. That will not be able to carry this concept, because it's going to be pretty CPU intensive, considering we don't have SA1. If we had SA1, we could use this routine. It would be perfectly fine. We can optimize for space, but with the resources we have, we do really have to optimize for speed. So that's what we're gonna do. Save the cycles, save the frames. We're not even gonna save the frames, we're gonna save the cycles. even smaller units. I should have some Super Metroid music going or something. Let me just, let me do that. Let me get, no, not Super Metroid. Let's do this, Surface of SR388. SR388, yeah, that's right. But from but the AIM2R version. Let's go with that one. That's the best version, because this is the best version of Metroid 2. So what is it we do here? We I think we do this. We wanna get that. We compare to 8, right? It's something like this. I'm somewhat familiar with this routine. Interestingly enough, like the speed routine in Super Mario World is the exact same one as the one in Zelda 2. Presumably Nintendo has used this routine on a lot of platformers they have developed. Or what was it? What are they called? The SRD, right? The company that hadn't actually merged with Nintendo yet at the time, but around the time that Super Mario World was developed, I think just after they developed Super Mario World, the company SRD was bought by Nintendo and became like their in-house programming team. And before that, they had just helped them like program a bunch of games. Pretty cool story in my opinion. So we get this X speed. We only care about the upper nibble because this is how many pixels we move every frame. And then we just add this to X high, no, to X low, right? And then we need to make sure we also... What is it we need to make sure to do? I don't remember. We need to also use subpixels. Let me just find those. I don't need to find those. I can just. I have to use the defines anyway, right? RAM, sprite regs, X sub. It's pretty common for these to be referred to as fraction bits, but I think that's really weird. It's only in it's only really on Super Mario World Central that people call these fraction bits. I don't know why. Everywhere else, people just call this subpixels. So I'm gonna call it subpixels, or X sub and Y sub. See here, it's called sprite Y fraction or sprite Y frac, but this makes it seem like it's part of the speed, but it's not. It's actually just a subpixel. So this name is very misleading, but it is what we have to call it, right? Here, Y X sub and Y sub. So now we go back down here. Was it? No, here is where it was. And if I can remember what I was doing. So clearly, obviously this determines the direction, right? It was a while since I messed with this. I really don't want to look into the like extra Mario World code again. That's the sort of last resort here, right? So we can look into all.log though. Let's do that. It can be a good example, I suppose. Here. Here, and let's see here. Let's see it. So we just add this. No, we do this. Okay, return if 0, of course. No, come on, man. This is why I love having sub labels, because then you just put the like done label like everywhere. It's like a plus label, except I actually know what it means because I can just read it. It's a word and I can read it. There we go. So we're gonna do the subpixels first. And I did know that this was like what you do with subpixels. So for this, like when we just add to the pixel, we ignore the high bits, or we ignore the low 4 bits, the low nibble. So we're gonna apply that here. Yeah, I guess we have to do that. And then we add to X sub, store to X sub. I think we have to do something with this as well. We don't use that again. All we do here is PHP twice, really? Why? Oh, because you want to store to this as well, is that it? That doesn't seem very useful. So this like stores like how many pixels the sprite moved on this frame. I don't think we need that. So what this routine does is it uses Y as an extra carry bit, or as an extra carry flag, as you can see here. We get the speed, compared to 8, BCC, get the negative flag. This is the exact same sort of thing that we do in the graphics routine, you know, when we're comparing to 80, and if it's greater, we add FF. That's to convert it to a like negative 8-bit number into a negative 16-bit number like this here. But what this does is it converts a negative 4-bit number into a negative 8-bit number. It's the exact same idea, just with fewer digits. And it actually skips past both of these, and it turns y from 0 to ff. And then here we're adding y to the high byte. PLP push a add store. Okay, so this is the PHP from if this turned out to be, if this pushed the carry flag or not. All right, fair enough. So we push P here, PLP here. I guess we really do, yeah, we definitely have to fuck with the carry here because we're gonna use LSR a bunch. Yeah. So we're going to turn this into BCC3, and then we want day here. Instead of CLC, we just want the PLP to restore the carry flag from here, from adding to the subpixel. So this is where we need the extra carry flag, right? Because we're using this carry flag here from the subpixel to apply to the normal pixel, but then we also need the next carry flag to apply to the high byte. So we use C to add to X low, and we use Y to add to X high, and that's why we're using Y in the first place. This extra like PLP, PLA, PLP, that's an example of one of the stuff that we are skipping by writing our own routine. It's not something we will ever need. It's something that can be useful to have in your sprite engine, and some sprites do make use of this, I guess. I don't know which ones, but I'm assuming some of them do. Probably something like Lakitus Cloud, or like platforms that need to know exactly how many pixels to move Mario for them to not appear out of sync. But we don't need anything like that. If we do, we can easily add it here as it's just something we write to scratch RAM, and then like if Mario should move, then we move him that many pixels, right? So this should take care of the movement, but we still need to make sure that the sprite interacts with objects, right? Let's just make this real quick and see if the sprite moves. He should have no gravity. Done, redefined. Oh, I see. Y adjust is what this is gonna be called. So there should be no collision, there should be no gravity, okay? He doesn't move at all. He don't move. Okay, so we messed up, I guess. Let's see what we're doing. X speed, if it's 0, we're done. Okay, it should be 8 though. So we're multiplying by 16. We're adding to X sub, we're storing to X sub. Save this carry flag. Load Y 0. Get speed again. This time we look at the high byte, but we move it down. We look at the high nibble, move it down into the low nibble. Compared to this, if it's less, skip this. Oh, this is why. We're not actually storing to the coordinates. See what we did there? I was like, oh, this is gonna be so good, and then I added everything up and then didn't store. So that's simple error, and now it works exactly as before, except it's probably using the cycles. So we are gonna do something about collision as well, and we're probably gonna use the exact same format because that's what we're all used to. If someone ever like messes with this in the future, it will make it a lot easier for them to understand. And we definitely need collision for the later phases as well. We might actually use the default version for the later phases, or the default speed code for at least phase 3. That's gonna be the least intense, like on the CPU anyway. So okay, move What do we do about that? So we need to define points that will be the collision point, and Y adjust. I guess we'll do this first. Collision. This is usually something that is a pretty beefy routine. Like, oh, if you could see the the terrain collision routine for Extra Mario World, oh boy. But we're gonna make it as simple and bare bones as possible, just to save cycles. Because this boss only has to work in this one level. It's fine if this is like pretty crummy, pretty scuffed. One of my new favorite words. So, what are we gonna do? We are going to first off clear the collision flags. I think I called it blocked, and that is correct. This kind of irks me. Let's move this up with the rest of the physics regs, like so. Kind of want to put it there. Okay, and then we go back here. So what we do is we get these points. I don't know what they're gonna be. They're gonna be like, I don't know, +10, I guess. Seems fine to me. Sound good? DA. Let's do Y first, because that will be more important. And then also here. Let's apply gravity as usual. We do this, even we don't include that here, because then like if Y speed is 0, then you also get no gravity. That makes no sense. We get Y high. You can't just load this in 16-bit mode, because these are not next to each other, because Extra Mario World, no, because Super Mario World programming is very smart. Then we do this. Is this even faster? I don't think it even is faster, because we have to switch here and then we have to switch back again. We'll see if we can make do. How do we do this again? I don't remember. But we're gonna get this. We're getting this point. We're gonna have to make another map 16 read thing. Like so. Little height. Did I didn't actually make this into define, did I? 13d7. I didn't. I totally didn't. We're gonna take this. We're gonna call this level height. You can't see, did I spell that right? Level height, yeah. Yeah. I didn't want to click all because I wanted to see what I was changing in case I like put it somewhere weird. RAM level height, like so. We just want to make sure that we're within bounds. BCC, I guess we do it this way. Just make damn sure that this is actually gonna match the height. Or we just call it within bounds. Yeah, let's do that. Within bounds. Bounds Y. Otherwise, we just load level height. We subtract 10. Store to whatever. Then we get, let's see, what do we get? X low. Like so. Add that there. X high, I guess. Then we get that there. I guess we don't need to be 16-bit yet. We can just go there, 16-bit A, and then we can just do the Y. I think this is faster. Saves both these opcodes, right? At the cost of an extra rep later, but I think that's good. And then we get done. Actually, what we do is we move this later. X done. X done. We call this screen done. So if screen is 0, this is done. If it's positive, calc screen. Actually, if it's I guess if it's negative, we just go to like X done, I guess. And we just don't change this at all, right? If this is negative, it means that we're like on the left, outside the level on the left side, so we just turn it to 0, right? We snap it to 0. I guess here as well we should. So this is sort of troublesome, I guess. So here, I guess what we're doing is if we are negative, we I guess we'll just do this. If we're positive, we proceed as normal. If we're negative, we just load 0, right? So if we're above the top somehow, we just snap to 0 as well. We don't want to index with anything invalid. If we're like off the screen on the right side somehow, like that's less troublesome usually. We're just gonna get a big index, but we're not gonna get an invalid index. I guess we don't really need to worry about the like bottom part either though. All right. Anyway, so we calculate the screen. So what we do is we get we add level height. I like to do this when I have multiple branches off the same thing. Then I don't like to like do the colon thing. Makes it less clear to me what is actually happening. B&E calc screen again. Otherwise we're done. Store there, and then we get the lowest nibble. So now we have this, which is going to be yeah, I guess we're going to 8-bit A as well. No, map 16 high. Is that what we do? Yeah, I guess it is. I guess I can do it that way. I guess I want to have. So this one is the most likely to be different, right? This one is the most likely to be. Because it has to be exactly 25 for this to be air, right? So we compare to 25. Air. No. Just done, completely done. Haha, I love this label. Otherwise we load this and it has to be exactly 0, right? Set collision blocked. Like so. So that should do it. And then we also want to make sure that what we're doing is we're taking the, here, we're gonna take the sprite's Y position and we're going to snap it based on this, right? So let's call this down collision. Yeah, let's call it that for now. Down collision. Get Y low and we keep the high nibble We subtract. This already snaps it there, so I guess we can just do that. We're adding exactly 10, so this should work out. Might be that we're like 1 pixel off somehow, but we'll see. Let's see what happens. Oh boy! That's not supposed to happen. It looks to me like the boss is actually like... So the gravity is increasing for increasing the speed past the positive point and turning it negative. That's why the boss is like bouncing like that. So I guess we're gonna have to do this. Y speedo, speedo. If it's negative, we'll always apply gravity. Otherwise, we compare to what's going to be the max fall speed. I think 46 is what it is for Mario. I guess we'll use that here as well. What do we use here? If it's less than this, we do... If it's greater than this, just no gravity. So it won't snap it to this if it is greater, but it just won't increment it further. I think that's the best way to do it. Okay, so the boss did actually snap to this, but it's one tile down, as you can see. How is that happening? I thought this would be the same offset. Maybe we should be adding F? I'm not sure. Instead of adding 10? Yeah, maybe here where we're adding 10, maybe we should add F here actually. Maybe the 10 is making it like snap to one block too much. No, that's the exact same thing. So I guess we really here. I guess we really should do that. I guess, and then we do. If no BCS done is what we do, and then we just decrement Y high like so. That's the exact same thing. It's the exact same thing, dude. Whoa! It's not, it's different. Something's happening. Something is rotten in the state of Denmark. Okay, let's see how it reacts to this stuff. Oh? Okay, okay. Oh, no. No. Oh, I'm so stuck here. Bro. Okay. So he's doing something. He's doing something. He stopped spazzing out. Oh, it's because he's at the cap anyway. It's at the downwards cap. Okay, so how do we snap this? So let's step through this. I think that might be best. I'm not really sure what's happening, so I'm just gonna step through it. I think that's best. Here. Right, this is not SA1. So we get this, right? There's Y position for sure. 194. Why is it 194? How is it 194? It's crazy. Oh, it's at Mac. Of course. It's at. It really should be at 190, right? But it's at max speed right now. Is that right? So it's falling at 4 pixels per frame. So this is. Why is it at 190? It should be at 1AO, right? Okay, let's just step through this. Okay, so we get A4, so we're already like really far down. Whoo mama. BPL, whatever. So we get this. Oh, I'm not even reading the right tile, am I? What is happening? Wait, what did I just do? Here. So I have that. Store here. Oh, because this is 1. What? Hey, what's happening? Oh, I'm reading X low, is that right? It should be X high, obviously. No, this is X low. This is X high. What is wrong? Load here. Store there. This should be 0 and is 0. So we go here. Then why in the world is what? Oh, this has to be here, of course. So that's one thing. All right, whatever. We're still reading a tile, it seems, right? We're still reading a real tile. X equal to 034B. Is that even good? I guess. All right. So we're 1 screen ahead on accident, but that's we're able to fix that now. No, we're actually reading an air tile. Interesting. Very interesting. This is also off. Only one has to be different for this to be different, of course. Oh! This is clearly not what we want. Seems like this is triggering incorrectly. So what should happen is that if this is exactly 25, okay, I get it. Oh, that's so maybe this was right at start, but this stuff wasn't. It seems like that's the case. So I guess we'll do that. See if this works. Comment out the right lines and see if it will work its wonders. No! Fucking damn it, dude! It's still... Ah! It's still stuck in the damn ground. And it's not gonna fall down either because it's capped. It's fucking capped. Oh, how annoying. Oh, I didn't even do this as well. Oops. Okay. This time for sure. This time for sure. Let's go. Yes! Yes, queen! Oh my gosh. Stop! Stop it! Why did he fall down? That doesn't even make sense. Did his speed become so high? His speed should be capped at 46, right? Should be exactly 40... 47, 48. I don't think 46 in hex is a multiple of 3. No, it totally is. No, it isn't, because 64 is not a multiple of 3. 63, so it should be 48 hex. So why did it fall down suddenly? Why did that happen, ladies and gentlemen? Let's try to figure it out. Let's try to figure it out. Debug. Yeah, I know it's a little lame to just debug all the time, but we gotta do it. Sometimes a man's gotta do what a man's gotta do. Here. So let's step through this. Does this look right? 190, that's good. So we're reading this tile, right? Oh, right, it's quite possible that, so the coordinates is here, right? This yellow thing is showing the like exact coordinates of the boss, I'm pretty sure. So I'm trying to read this tile. I'm reading the very top pixel of this tile, right? Let's see here. 190, right? So here. Yeah, 25 in hex 19. So I'm reading the very top pixel of this tile. See here, get this, it's screen 0, whatever. And 7. Oh. Oops, that's not how you read the correct coordinate. It should obviously be shifted right 4 times. That's why this is not going well. Alright, that could be. So when it fell down, it was because it read like a tile that was like way over here, right? That was randomly generated. So here. Those are 4. You can do this, or you can like do this if you want. It doesn't really matter. I guess I like this better. Makes it more clear that like what we're getting are like 4 bits in the bottom. Come on, please work. You're working, okay? Yes, yes, queen. Okay, now we need to make it respect like 1 tile tall walls and walk up them. That's the next step. So now we need to look for we need 2 more collision points. We're probably gonna have a lot more collision points by the end, but down collision point. So I guess we're gonna turn this into a JSRable, I think. All the way here, I think. This is where it should stop. This is music I run to. This is crazy. I can't listen to this while coding. I'm gonna get stressed out. I'm gonna get too pumped. Let's change the music. Okay, that's good. Input. What should the input be? I don't know. Probably like offsets or something. Ugh. Isn't that sort of slow? I don't know. Maybe. How flexible does it have to be? I don't even know. 0, 0, X offset. I don't really like this. Y offset. Is that right? Or do we just like put these as part of the JSR maybe? C style. Like if you always want to pass the exact same amount of data, and we're never gonna like make use of these being flexible, I think it makes more sense to do like here, just get map 16, and then we just put the offsets here. Like the X offset is 0, Y offset is 10, and then like as part of this, instead of just JSR, we just here. So somewhere here, like here, right? So we add, would add this. No, wait, that doesn't work. We would have to set up a pointer. Oh, that's so slow. No. This is stupid. Forget I ever suggested this. This is terrible. This is absolutely terrible. I would have to set up this. Is it even terrible? Is it actually terrible? Is it terrible? How bad is it? Now I want to know. I'm really curious now. How terrible is this? So you would need like, get this, like you read the JSR address, which is going to be this, right? I think you have to add one, store it to like here, whatever. Then you like increment it by 3 and store it back here. Is this even that slow? Maybe like pointer to X offset, pointer to Y offset, and return address. How slow is this? I'm actually gonna have to look this up. I don't know. Maybe this is actually like secret genius. So that's opcodes. Let's see what we're doing here. So like, just a heads up, like I don't really know what I'm doing right now. Like this is just an insane idea I got. LDA, DPS, SRS, right. 4 cycles. 4 cycles. Store, SRS, also 4 cycles. Of course, 4 times 2 for inc 4 total. Let's just do 8 for inc 4. Store DP. And this is, I think 3, right? Store DP is 3. 3. So this doesn't actually cost very much at all. And we save, but the only thing we save is having to we could do that, or we could do that, right? So what's that? So that's 12 plus 2 is 14. What does this add up to? A lot, right? 16, 22. Yeah, this is 14. Yeah, 14, 22. Seems like this is just better, honestly. This is just better. This is kind of fancier, but it's honestly just way worse. It's honestly just way worse. And this is 3, 6, 8, 11. So this one is by far the best. By far the best. Sort of disappointing that like weird shit like this doesn't actually end up being very useful, I guess, but it is what it is. Seems like by far the best thing is to just write the X offset to 0 and then A equal to Y offset. This is gonna be the offset. Come on, this looks a little weird, I guess, but both 16-bit. There. Hello, Anon. Welcome to the stream. Sorry, didn't notice you there. I was in another tab looking up really weird optimizations. I considered like passing values to a routine via the stack, but it turns out that's just way slower than doing it normally. So we're doing it normally instead, even though that's a little less interesting. So we're doing this. We're gonna read this tile here, turning this into a routine. So it turns out that the boss I'm making is pretty big, so and I don't have access to SA1, so I need to really optimize for speed when coding this. So I can't just use the default routines for like collision and speed and stuff. I have to actually rewrite them and include them in the boss file. So we're gonna end up with a really big file at the end. Hopefully the space isn't a problem, because I'm pretty sure the speed would be a problem if we didn't do this. So here, how do we want to end this? So here we're only getting the Y offset, right? So that's no good. So what we do is we put this in 2. I guess we'll add another sap. SD2SNES is a weird bug, and that run fine in all emulators except SD2SNES. You really don't know what's failing. What did you do? What code did you use? Do you have any way to share it? I'm really curious what exactly you were trying to do. I have found, like over the course of developing Extramarble, I've found a lot of weird bugs with different emulators. I have this really weird bug that only happens in SNES 9X. It's really weird. It's like sometimes when like the camera scrolls in a specific way, you'll get like garbage tiles on the screen. And it only happens in exactly SNES 9X. In no other emulator does it happen. So I have no idea, no idea what causes it. And it seems to be an emulator thing. It's sort of weird to develop for emulators, right? Because you don't really know which standard you should use. You just have to sort of do your best and hope it works on everything, right? Do we really go back into 8-bit A here? That seems pretty terrible. I think we don't do that. I think we don't go back into 8-bit A here. I think what we do is we just set this up beforehand. We put this in C and E, I am deciding right now. Like so, and then we're stored at the 0. And then here, screen down, no, where are we? X high, X low, whatever. Within bounds, stores to 0. So here, we get this coordinate here. And we get this instead, there. You already reported on the SD2SNES repo. That sounds nice. So we fix this, and then here we get, of course, C instead of that, and then get map 16. Let's see here. We have to add some other input here. We have and of course A is a Y offset, saves the 3 cycles that it costs to write to DP. Also saves the 3 cycles it costs to read from DP, right? C is X position and E equals to Y position. I think this is gonna be pretty good. Output map 16 number 16-bit. And then also A equal to map 16. Oops, map 16 number 16-bit, but A is 8-bit. X equal to sprite num. Returns all regs 8-bit. Okay, so I have to set up the coordinates here now. Like so, and here. going to be y high, there's going to be y low, there's going to be x high, x ho, ho ho ho. Okay. Here. I'm pretty sure this will trigger all the like usual flags, including the Z flag and N flag. Not that we need the N flag. N flag sounds like vaguely inappropriate. Okay, so sub labels unacceptable here. Main, whatever. Salvage the subs. Okay, here we go. Let's see. Does he do the thing? Does he do the thing? Come on, hold your pink. No, he doesn't do the thing. Damn it! Wait a minute. What in the world? Did he just do it differently? Wait, I just rewound and he did it differently. I guess that has to mean we randomly generated another chunk. Yeah, that's right. Okay, so he's not reading from the correct screen. I guess that's the case here. So let's see what we can do about that here. Store this, add this, whatever. Has to be positive. Yes, thank you very much, Anon, for catching that. Has to be within the level. I mean, what do you call it? Negative flag is way long. N flag. I kind of like that it sounds like something you can't say, right? He just said the N flag! No! That's so funny. Oh wait, where am I storing to 0? That doesn't work. Oh my gosh, I'm storing to 0. Let's just put this in like 8 or something. 8 is good. I like 8. Store to... Yeah, store to 8 here. Yeah, right. And then we add 0 here. Store to 8. Like so, that will do. That will do. Like that. Oh no, wait, this won't do at all. We have to make sure that these are not shredded. It's really bad if these are shredded. So we're gonna change the output quite a bit here. Damn it, stop! 4 equal to x coordinate of point. 6 equal to y coordinate of point. And then x offset, y offset, not shredded. We want to make sure we don't shred these. That would be that's gonna make this way more convenient for later. So we're just gonna use more memory to save cycles later. Store to 2, very good. Y offset not shredded. Add E. 8 equal to map 16 number, so we can use this as scratch, whatever. We store this to, what did we store it to? Right here. So y coordinate point store to 6, x coordinate point store to 4. So load 5, and then here we load 4, right? LSR 4, yeah, that looks right. Except that this here is way off. This should be 8, and this should be 9 and 8. And return with the low byte loaded already. Actually, we return with, let's do that actually. That should be good. Should be very good. Okay, let's make it, test it, everything. Okay. Come on. No, oops. Do the thing now, boss. Do the thing. Please do the thing. Okay, he's doing the thing. Awesome. As you can see, Anon, I added a like hard cap on his Y positions. Like, even if there's nothing solid here, he doesn't like fall further than this. Okay, now we have set this up. Now we can really make this efficient, right? So we're going to use this flag here. Down collision point, very good. We are gonna move this up. Reset stuff. Down collision. Down done. done. Okay, here. Now we add forward collision point lower. And this is gonna be the one that makes the boss like move, makes him move up, you know? Yeah. I saw you did that. You recorded first and then recorded voiceover later. Seems like a pretty smart way of doing it. Seems like it's a good way to avoid a lot of mistakes. So let's see here. What we want here is rep 20, and then we want, let's see, add that there. Let's see which what offset do we want here. We don't want it to be as far down. We probably want like 8, I think. Get map 16 down collision. No, not down collision. This one is going to be called corner collision. Corner done. Yeah, it's pretty common for people to say like or stuff like that. I think during one of my lectures at university, I counted how many times my professor said during his lecture, and it was like 150 times in an hour. It was ridiculous. I lost count after that. So like, don't worry about it, man. Like even really experienced people say a lot. What was I gonna do here again? All right, the boss moves up, right? Let's just I don't know, give him some Y speed or whatever. Will that do it? I think so. Make. No! Corner collision wasn't found. Okay, let's see. He should be able to do it. He should be able to walk up here. Let's see it. Let's see it with our own eyes. And he totally does it. He totally does it. It's really choppy, but he does do it, okay? Did you see that, Anon? Did you see that? That's so awesome. That's so cool. Yes! Let's go! Okay, so why is it so choppy? Let's frame advance here. Moves up, 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 up. He stopped moving up. Oh, that's why he stops moving up, because the corner tile is too high up. Okay, yeah, maybe it's just set this at 10 as well then. Yeah, that should do it. Let's see. Nope, that's not good. Maybe 1 pixel up is good. Maybe 1 pixel up is good. Yes, I am doing my own object clipping routine. I have to save all the cycles in this. I don't want any slowdown during the final boss. That would be unacceptable, so... Come on, it's still happening! Really? Oh man, this guy is tougher than I thought. Wait, unless... No. Come on, man, this is ridiculous. This is stupid. Stupid, stupid, stupid. So, what's the problem here? I guess what we have to do is we need some sort of flag to like remember when it starts climbing up the stairs, or when it starts climbing up a block, right? And once it starts climbing up a block, it needs to like disable its bottom collision for a while. I think that's what we need. Maybe. So we put this here. I think at this height is good. No, this height wasn't good at all. Let's try C. And then actually we're gonna cap the down speed to 40, I think. Here. Gonna cap this to 40. 46 is a weird number to work with. BC, and we can't actually do this. BCC gravity. And then also here. We also need to do this. I guess I can just do this. Compared to 40, BCC. Ooh, BMI gravity. That's right. I guess I'm not really sure what I'm doing here, so I guess let's do this. Compared to 80, I guess. BCC gravity done. Let's see, you detect walls or cliffs to avoid that the sprite is dead. It detects the position where the player was touching the ground. Then if the sprite detects a wall or cliff, it jumps to that position. And do a jump to that position. It's a very aggressive and cool way to fix that. I don't see what's aggressive about it. Or I guess I'm misunderstanding something here. When you detect walls or cliffs, to avoid that the sprite is dead, what do you mean avoid the sprite being dead? What does that mean? Avoid the sprite like going into walls and stuff? Yeah, that's exactly what I'm doing for the down collision actually. I'm just snapping the position. I think that's how I'm interpreting what you're saying. I don't really know what you mean by like avoiding the sprite being dead. If the sprite falls on a cliff, okay, yeah, keep going. I'll read it when you're done. BCC and then. Wait a minute. Let's try that. Oh, something's happening. Oh, that's not really supposed to happen, eh? Okay, so it's still like vibing like crazy here because it's like, Okay, I guess what we should do is make sure this actually snaps to position. Down collision point. I mean, this is a pretty good argument for. There's a pretty good argument for just passing coordinates instead of offsets, but this is so much easier for like doing multiple ones. Except here, where it's actually an issue instead. So I guess what we're doing is we're getting this like so. Do that? Is that right? Yeah, okay, so detecting terrain, doing the whole system to detect terrain on an intelligent level and avoid that sprite do something weird. Instead of that, you do make it so the sprite jumps to a position where you know that it exists ground because the player has already been there. Okay. How do you just save every position the player touches ground at? Like, how does that work? I don't really understand how that works. Like, what sort of how do you keep track of where the player has been? Okay, it seems like this should work, right? So now it checks higher up. You can save a point every few frames. Okay, so it should... Oh, oops. Oops. That's not really meant to be how it works. Okay, so it doesn't quite work. So this minus 10 here was a bit much, it seems. Okay, yeah, you can do that. For example, every 32 frames. Interesting. I've never thought of doing that. I have considered like having, have you seen these like AI learns to play Super Mario and stuff? I was really inspired by those, and I was like considering making like something similar in ASM, like having the sprite like do like a rough reading of the map 16, but it just felt a little ridiculous. It seems like your system is pretty good. Usually I just give my sprites like a moveset where it doesn't really matter if they behave smartly. Let's see. So why is it spazzing out like this? So I guess at this point, like I shouldn't just keep trucking. I should actually think about what I want this guy to do, right? So like how, okay, why is this happening? Right. Okay, so what's happening here is that he tries to move up, but the like down collision, right, the down collision is triggering even though he's moving up. That's what's happening. That's what's happening. So what we need to do here is down collision point. We read x speed and no, y speed and BMI down done. No down collision when moving up. There we go, baby. Here we go. Let's see if it works. No, it doesn't work. It still doesn't work. How what? How does it not work? This is crazy. Yeah, yeah, maybe. Maybe. Depends on what you do. It really depends on what you do. So you can actually do some stuff. I think I actually coded it. I think I actually have a video where I showed it off, but I didn't tell anyone I had made it. I don't think anyone noticed either. So what I did, something I have done, is make a sprite that like chases the player, right? And the sprite can jump. The sprite will always jump when it like runs off a cliff. So if you have like, let's say you have like the cliff here, and the sprite is Mario's here. Mario like jumps off here to the like the next area, or whatever. The sprite is here. The sprite will always jump here, and I thought that. If the sprite can jump, like, what if Mario is like on a platform like this above the sprite? Like, why can't the sprite just jump to Mario? Like, it has the jump height. And then I made it actually like check for blocks, like at a certain height. And if it saw a block, if it was running here and saw a block here, and Mario was above, it would actually try to jump towards Mario here. I thought it was really cool. Then I removed it. I don't remember why I removed it. Maybe it was like too difficult or something. Let's see, what did you ask about? What are the contact positions? Because if a side contact point is in the same X position than a ground or sealing point, then that is an issue. It's not the same X position. The side point is, let's see, what is it? It's a full block to the side, which I think should be good. And let's see, now I also made it so that when the sprite is moving up, it can't, the down collision is disabled now while the sprite is moving up. I don't know if that will help. I think it will help, but I don't know if that will solve it. Let's see here. Okay, so this is really weird to me. Well, it starts moving up for 1 frame, but it should take it way longer than 1 frame for gravity to catch up to the negative speed it gets from touching a wall, and then this happens. What I'm really curious about right now is what is happening with Y speed here. Did I mess up here in the gravity check? BMI gravity. Increment 3. Oh, BCS gravity done. That's how it should be. Okay. Yeah, there we go. That was it. That was the issue. We found it. Check this out. See, it falls down. Okay, that didn't work either. So let's see what is going wrong this time. So he goes in here. Here we trigger the side point, right? And he starts moving up. Then we stop triggering the side points. The side point is no longer being triggered, right? Because he starts moving down. And why is that? And I think I know why. It's because I added this like stupid thing here. I tried to... Why did I add this? This is so dumb. Why did I add this? Alright, whatever. Let's just do 0. Try that. Like so. Full block above. That should work. Check this out. So now it's gonna move up, right? Okay, that sort of looked janky, but that was also like a thing. Okay, this still is super janky, dude. This still is super janky. Oh, oops. Let's see this one tile. How does this work? Moves up, and then it stops moving up. Okay, so checking like here, right? Checking here right now. I guess it actually has to check more than 1 point. That's the only thing I can come up with. Forward collision point 1. Corner collision. Corner 2. Okay, so we're doing this instead. We're gonna add an extra collision. Oh. This music rules. Metal Gear Rising Revengeance, man. Sick stuff. Okay. Let's see if this works. So I added an extra point that should add some consistency to it. And that does help a lot. Did you see that? That looked a lot more consistent. So it doesn't work super well, but just somehow I guess that one, the second point needs to be like further down. I think the first point is just too high up, man. Here. Let's put it at height 8. The second point should probably be further down. We don't want it to be too far down. We want it to be... So we know C is too far. B might work though. B might be perfect. Yeah, because it's not triggering on flat ground. That's good. But now this should be a lot more consistent. Yeah, that worked perfectly. Let's see, does it work here? It does work. It does work pretty well. I wouldn't say that's perfect, but... So what is the problem? The problem is pretty simple. The problem is that the first point triggers, and then the sprite moves above where it should be for the second point to take over too soon. So that's the real problem here. Yeah, it is a little bit weird. That's not how it's gonna behave later. So what we're gonna do is, do we still have the paint up? We're gonna make it so like one tile, if it's a wall like 1 block high, it just walks up it like it's a stair. If it's 2 blocks or more, it's gonna smash the blocks. No, it's not gonna jump. This is gonna be like a big mech with like big feet that like with legs and stuff that walk forward. So it's not gonna look strange when it can just walk up because it's gonna be so big. So it would be weird if it jumped. But if it's taller than 1 block, if it's like 2 blocks, then it will smash the blocks instead. The blocks will just explode, and that's gonna be pretty cool. Don't think we have time to get there today. It took longer than I thought to make this like collision detection. So we have that. This point isn't perfect. Maybe it should move forward like 2 pixels. I don't think we're gonna adjust the sprite's speed all that much, and I don't want to add too many collision points either, because, you know, we're saving the frames, saving the cycles. So we move it here. Look at that. Was that even any better? Let's see here what happens. No, that's not really better. I guess this doesn't have to be 10, this can be E. So now it's at like, I'll put it as C. CA8. That should be, this should be like maximum consistency. This should be really good. Let's test it. See if it works. That mostly worked. That wasn't quite right. Oh, it's because it doesn't move far enough up, and then it starts falling, and then it touches it, and what? It's still not. Huh. That still didn't trigger it. That still didn't trigger the down point. Maybe we really do need to add a second down point. Yeah, I guess we need to add the second down point. Oof. Down collision points. Here. Yeah. Oh, this isn't on 8. I see, this is on 0. Okay. This is... the entire time I thought it was on 8, not 0. That kind of explains everything, actually. So we put this on... yeah, we put this on C. That seems fine. Now this should work just fine. This should be very different. Oops. Okay, that worked. That worked perfectly. Okay, that actually explains the entire crux of it. I thought the down collision point had the coordinates +10 +8, but it actually had the +8 +10, but it had the coordinates +0 +10. That's why this was so janky. But now it works. See. We are going to adjust the initial Y speed while the sprite is on the ground for sure. I think this is good. I really like this. I really like how this looks on the 1 tile gaps. Look here. Walks up, walks up. We are gonna make it destroy blocks tomorrow on the next stream, but for today I think we are done. We went for a pretty long time today. We're gonna change the name of this one. It's gonna be collision. How do you spell collision? Like that, I think. Collision detection by hand, I guess we can call it. Collision detection by hand. There we go. So thanks for the watch, Anon. You're my best viewer by far, man. Like, it's always interesting when you're here. You always have like stuff to say, and I feel like you actually understand what I'm doing, which is awesome. Hopefully someone else will watch this at some point and learn something. I don't know. But for today, that's it. I'll be back tomorrow. Keep working and stuff. Hopefully we get some response on the Discord as well regarding the graphics. But I'm sure everything will be fine. So thanks for today, man. Bye.